Hi all, I am Shreya, MSc Computer Science student, Department of Information Technology, Kannur University. Today's topic is identifying non-regular languages. Here, to decide whether a language is regular or not, we are using a theorem known as Pumping Lemma. Pumping Lemma is used to prove a language is not a regular language. Now we can look what is Pumping Lemma. Pumping Lemma is a powerful tool for proving certain languages are not regular. It is based on the concept of pigeonhole principle. Now we can look what is pigeonhole principle. If there are n pigeons and m pigeonholes with n greater than m, there must be at least one pigeonhole with at least two pigeons in it. That is, if we are having n pigeons and m pigeonholes and number of pigeons greater than number of pigeonholes, there will be at least one pigeonhole with at least two pigeons in it. For example, we have 4 pigeons and 3 pigeonholes. Here, number of pigeons are greater than number of pigeonholes. Then, a pigeonhole must contain at least 2 pigeons in it. So, this is the pigeonhole principle. Now, let's look Pumping Lemma for regular languages. Let L be a regular language. Then, there exists a constant m which depends on L such that for every string w in L such that mod w greater than or equal to m, we can break w into 3 strings w equal to xyz such that y not equal to epsilon, mod xy less than or equal to m, xy raised to iz belongs to L for every I greater than or equal to 0. Here m is the pumping length. Y not equal to epsilon means y should not be null. Y should be always greater than or equal to 1. Mod xy less than or equal to m, xy raised to iz belongs to L for every I greater than or equal to 0. Application of Pumping Lemma. To prove a language is not regular, in Pumping Lemma, proof by contradiction is used. We will start by saying that language is regular. Here are the steps. Step 1. Let L be a regular language and M be the pumping length. Step 2. Choose a string W such that mod W greater than or equal to M. Use Pumping Lemma to write W equal to XYZ with mod XY less than or equal to M and mod Y greater than 0. Step 3. Find a suitable integer I such that xy raised to iz belongs to L. This contradicts our assumption, hence L is not regular. So, now let's look at some examples. Prove that L equal to 0 raised to n, 1 raised to n such that n greater than or equal to 1 is not regular. Here are the steps. Suppose L is regular and m be the pumping length. Select a string w such that mod w greater than or equal to m. Here I am assuming m equal to 8 and w equal to 0, 0, 0, 0, 1, 1, 1, 1. By taking the value of n equal to 4. We can break w into 3 parts x, y, z such that x, y raised to I, z is also in L for some I. Case 1. Y part contains only zeros. Here I am splitting x, y, z. X contain 2 zeros, y contain 2 zeros and z contain 4 ones. Let I equal to 2, then x, y square z equal to 0, 0, 0, 0, 0, 0, 1, 1, 1. That is, x part contain 2 zeros, y part contain 4 zeros and z part contain 4 ones. Here number of zeros and number of ones are not same, which means x, y raised to iz is not in L. Next, case 2. Y part contain only ones. Here I am splitting x, y, z. X contain 4 zeros, y contain 2 ones and z contain 2 ones. Let I equal to 2, then x, y square z equal to 0, 0, 0, 0, 1, 1, 1, 1, 1, 1. That is, x contain 4 zeros, y contain 4 ones and z contain 2 ones. Here also number of zeros and ones are not same, which means x, y raised to iz is not in L. Case 3. Y part contains zeros and ones. Here x is split with 3 zeros, y contains 0, 1, z contains 3 ones. Let I equal to 2. Then x, y square z equal to 0, 0, 0, 01011111. This is not in L. So the language L is not a regular language. Now let's look another example. Prove that L equal to WW such that W belongs to AB star is not regular. Step 1. Let L be a regular language and M is the pumping length. Here I am choosing the pumping length M equal to 8. Step 2. Select a string W such that mod W greater than or equal to M. Here I am choosing the string W equal to ABAA, ABAA. Step 3. We can break W into 3 parts, X, Y, Z such that X, Y raised to I, Z is also in L for some I. We can break W into 3 parts. We can select Y in any way. The splitting depends on W. While selecting Y should not be empty and mod xy less than or equal to m. Here I am splitting xyz as x contains ABA, y contains AA, z contains BAA. Let I equal to 2, then xy square z equal to ABA, AAAA, BAA. Clearly x y raised to I z is not in L. Hence, language L is not a regular language. Now, let's look another example. Prove that L equal to A raised to N, B A raised to N with N greater than or equal to 1 is not regular. Step 1. Let L be a regular language and M is the pumping length. Here I am choosing pumping length M equal to 8. Step 2. Select a string W such that mod W greater than or equal to P. Here I am choosing the string W equal to AAA, BAAA. We can break W into 3 parts, X, Y, Z such that X, Y raised to I, Z is also in L for some I. Here I am splitting X, Y, Z as X contains 3 A's, Y contains single B and Z contains 3 A's. Let I equal to 2. Then X, Y square Z equal to AAA, BB, AAA. Here Y contains 2 B's. Our language should only contain a single B. So it is not a regular language. Hope it's clear. Thank you.